Read a sentence. Maria is a doctor in Seoul. Now read another. Maria works in medicine. Does the first sentence imply the second? Yes, obviously. Any human knows that. Now try. Maria has never been to Asia. Does the first sentence imply that? No, it contradicts it. Now try. Maria drives a Toyota. Does the first sentence say anything about that? No, it's neutral. 3 possible relationships between 2 sentences. Entailed, contradicted, neutral. That's textual entailment. This task has a proper name. Recognizing textual entailment, RTE, sometimes called natural language inference, NLI. It's one of the cleanest ways to ask a model, do you actually understand what these sentences mean? Or are you just pattern matching on the surface? Last video, we found topic boundaries in unmarked text. Segmentation is about structure. This video is about meaning. Given 2 sentences that are structurally fine, we're asking a much deeper question. Does the first force the second to be true? That is a question about the logical content of language. And it's the reason NLI has been used for 20 years as the go-to probe for language understanding. Today's puzzle. Why would a research community obsessively benchmark models on does X imply Y? Answer. Because if a model gets this right consistently, especially on tricky cases, it's doing something a keyword matcher cannot do. NLI is the closest we get to a Turing test for meaning. Today's 3 beats. First, the task. Premise plus hypothesis. 3 labels. Entailed, contradicted, neutral. With worked examples. The setup, cleanly. Second, the datasets. SNLI, MultiNLI, Adversarial NLI. What each one added and why the field kept building harder ones. Third, NLI inside LLMs, near human on SNLI, still tripping on adversarial cases, why the gap says something important. Beat 1, the task. Given 2 sentences, call the first the premise, the second the hypothesis. Pick one of 3 labels. Entailed means the premise forces the hypothesis to be true. Contradicted means the premise forces the hypothesis to be false. Neutral means the premise says nothing about the hypothesis. That's the 3-way NLI setup. It has been the standard framing since Bowman and colleagues published SNLI in 2015. Worked examples. Premise. Maria is a doctor in Seoul. Hypothesis 1, Maria works in medicine. Entailed. Because doctor is a subset of works in medicine. Hypothesis 2, Maria has never been to Asia. Contradicted. Because Seoul is in Asia, and being in Seoul now contradicts never having been there. Hypothesis 3, Maria drives a Toyota. Neutral. Because nothing in the premise mentions transportation. Every NLI label is either forced by the premise, ruled out by the premise, or independent of the premise. Where did this task come from? The original RTE challenges. Recognizing textual entailment. Dagan, Glickman, Magnini 2005 and 2006. Before them, entailment was buried inside larger semantics of language research. They isolated it, standardized it, ran a shared task at PASCAL, RTE 1 through RTE 7. That series established the framing that a decade later became SNL. Small history bump, big consequences. Beat 2. The datasets. Start with SNLI, Bowman, ANLI, Potts, Manning 2015, Stanford Natural Language Inference, 570,000 premise hypothesis pairs, crowdsourced. How did they scale it? They took captions from Flickr photos as premises. Then they asked crowd workers to write 3 hypotheses per premise, 1 entailed, 1 contradicted, 1 neutral. Cheap, big, balanced. The dataset that made neural NLI possible. SNLI had a weakness. Everything was image captions, narrow domain. So in 2018, Williams, Nangia, and Bowman built MultiNLI. Same setup, 10 different genres, fiction, government reports, phone conversations, letters, and more. Suddenly, models had to entail across domains. Then Ni and colleagues 2020 went one step further. Adversarial NLI. They actively hunted for examples that models get wrong, then trained a new model. Then hunted for examples IT gets wrong. Loop 3 times. That is ANLI. Notice the pattern. Every time a benchmark got saturated, the community built a harder one. That is the healthy version of Goodhart's law. It kept NLI honest. It also gave us a clean way to test. Does the current generation of models really understand entailment? Or did they just find the shortcuts in the last dataset? On SNLI, models hit 90+% by 2019. On ANLI round 3, even the best models still sit at 70% as of the writing of this course. Beat 3. What NLI tells us about LLMs. Modern large language models were never explicitly trained to do NLI. Nobody sat down and said in each GPT to label pairs entailed, contradicted, or neutral. But they learned to do it anyway. Because NLI is downstream of general language understanding, read enough text and the ability to say in this sentence forces that one to be true just appears. It is a good sign for the scaling hypothesis. But, and this is the important but, LLMs still fail specific NLI cases in ways that reveal shortcuts. Give them a premise that requires world knowledge to reason about, plus a hypothesis phrased with the exact same content words as the premise, and the model often says entailed when the correct answer is contradicted. Surface overlap fools them. That is the entire ANLI attack recipe, which is why NLI benchmarks stay useful even after models passes the older versions. The through line. Entailment is a probe. It is not the point of language modeling, but it is one of the sharpest tests we have for whether a model is tracking meaning or just correlating tokens. 20 years of RTE, SNLI, MultiNLI, and ANLI have produced a diagnostic tradition. And every time a new generation of models arrives, one of the first things the community does is run it on the NLI benchmarks, because entailment tells the truth about how much a model actually understands. 3 takeaways before the quiz. 1. The task is called RTE or NLI. Given a premise and a hypothesis, output entailed, contradicted, or neutral. 3 labels. Dagan, Glickman, Magnini set the framing in 2005. 2. SNLI 2015, MultiNLI 2018, ANLI 2020. Each dataset was built to be harder than the last. Adversarial NLI, in particular, hunts for the exact examples current models fail. 3. LLMs hit near human on SNLI. They still lose on ANLI round 3. That gap is diagnostic. NLI stays useful because it reveals when a model is pattern matching versus tracking meaning. Quiz 1. In three-way NLI, what does neutral mean? A. The 2 sentences are grammatically similar. B. The premise says nothing about the hypothesis. It neither forces it true nor rules it out. C. The premise and hypothesis are the same sentence. Or D. The annotator was undecided. B. The three-way split is forced true, forced false, or independent. Neutral is the independent case. Nothing in the premise touches the hypothesis. Maria is a doctor in Seoul says nothing at all about what car Maria drives. Neutral. Quiz 2. How did Bowman et al. 2015 scale up SNLI to 570,000 pairs? A. They wrote every pair themselves. B. They used Flickr photo captions as premises and crowdsourced 3 hypotheses: entailed, contradicted, neutral per premise. C. They translated an existing German dataset. Or D. They ran an LLM to generate all of it. B. A very clean trick. Flickr captions are already free text describing a single scene. Then, 3 hypotheses per caption from crowd workers, 1 for each label. Balanced, cheap, big enough to train neural NLI models. That is why SNLI became the anchor benchmark for a decade. Quiz 3. Why is adversarial NLI still useful, even though modern LLMs ace SNLI? A. It's smaller so it runs faster on old hardware. B. It hunts for examples. Current models fail. The benchmark evolves with the models, so it keeps revealing what LLMs still get wrong. C. It uses a different language than SNLI. Or D. It doesn't use neural networks. B. ANLI is built by adversarially finding examples. The current best model gets wrong, training a stronger model, and hunting again. 3 rounds. The result is a benchmark that stays hard as models improve. On ANLI round 3, top models still sit around 70% while humans sit near 88%. The gap is diagnostic. Back to the puzzle. Why obsess over does X imply Y for 20 years? Because it is one of the few tests where surface overlap does not save you. A model has to track meaning. And every time a benchmark got saturated, the community made a harder one. Entailment does not lie. Next video, how machines handle yesterday, next Tuesday, and soon. Temporal processing. Next time, temporal processing. Extracting dates, normalizing yesterday, resolving next Tuesday, dealing with soon, time ML, temp evil, SU time, the unglamorous piece that every calendar, contract parser, and news analytics system quietly relies on. Hit subscribe.